Thanks very much. I'd like to start off by picking up a point that Todd made on the last presentation of how can anybody ignore warnings when they're in front of you saying you're about to die. It's not as simple as that, and I'll show in a presentation, it's about 45 minutes, why. Well, it's easy to judge what goes on, and it's after the event, and it's really easy to join the dots after the event to say, it happened because of this. But unless you're in that position at that time, with that mindset, that mind training, that training and environment, it's much more difficult to look ahead. So my background, I'm still a serving officer in the Royal Air Force. Spent 10 years flying C-130s out of Lynham, the last 2 years of which was an instructor, teaching low-level tactical operations. When I left there in about 2005, I read a paper on human factors in aviation accidents. And I just started getting involved in diving as well. Recognized there was a lot of crossover in what I could read from aviation, accident analysis and investigation, taking it across to recreational and sport diving. Started a company a couple of years ago, Cognitas, to provide a bit of structure to what I was doing. And then January last year, I started a PhD looking at the role of human factors in diving incidents and trying to come up with a causality model that can be used by both the lay diver when they're conducting their own post-diving incident analysis, but also for the research teams out there to provide a common structure for data. And we're looking at incidents, it's not just fatalities, it's near misses. And then last year I launched the Diving Incident Safety Management System, DISMS, as a way of capturing that. And I've already had a number of groups come to me saying, can we use this as a basis for our own data collection? But it's a bit of a serious subject, so I thought we'd start with a bit of humour. And people, you know, to me, it's not just a failing of the diver because they don't know what they don't know. To me, this is a failing of the system in showing that the divers in the background weren't aware of what they were doing. So to start off with, I'll show a brief outline of a closed-circuit rebreather case study. Jared asked me to cover a rebreather one rather than open circuit because it just shows the complexities involved in moving towards this sort of technology. The guy involved was a fairly experienced guy, got about 1,000 hours on unit. They planned a wreck dive to 80 meters, but this had been, they'd originally planned on a 60-meter dive. The guy had some problems on the descent, things weren't quite right, alarms were going off, stopped at about 20 meters or so, thought, no, I'm going to ascend. His buddy carried on down and he ascended solo. Got to about 10 meters or so, and a couple of other divers passed him, and he's like, they've made it, I'll follow them down. So as he's going down, there's high PO2 alarms are going off. Ignored those. He doesn't know why he ignored them. He was aware of them, but he doesn't know why he ignored them. Got some fairly significant narcosis and bailed out. Very high breathing rates, and has started his ascent, and he was worried about running out of gas. Bailed to 50% early, at the sort of 35, 40 meter range because he thought he was running out of gas. Finally got himself back under control after switching back to his bottom gas. Getting up to 20 more meters, switched on to 50%, and then ascended normally from there. Now from my point of view, from an analysis side, this guy was wearing a GoPro camera, so he videoed everything. And when he jumped in, the camera knocked forward, and I could see the handsets and the computers that were going on. So there's about 40 minutes worth of video to go through this. It's a very useful tool. So there's the background for the study. Now, there's sort of superficial information there, and I'll go through now. That's the sort of normal level of information you get in a forum post or an incident report that comes up for public consumption. So start off with risk and safety. Risk is relative. It's very personal. People have been known to take, or the literature is out there, people will take voluntary risks 1,000 times more significant than involuntary risks, health and such like. So people choose to undertake risky activities. We choose to go in the water, which is non-life sustaining without mechanical or technical support. But your view on risk is knowledge and experience based, and is also influenced by the environment you're in. When we talk about goal diving, people have different views on what you need to achieve or what you're going forward, and that drives the level of risk which you're willing to accept. This video clip now shows a number of activities that have got varying levels of risk. This is off Northern Ireland, Malin Head, about 65, 70 metres. This is pretty good. They're on rebreathers, so there's increased risks already. But you can say that your buddy's pretty close. If I've got a problem, I can go to them. This is more usual UK diving. It's about 40 metres. So you're now 30 metres shallower, but the risks, I think, are greater on this sort of dive because you've got entanglement, losing your buddy. It's not particularly great. Then you look at this sort of activity where the risks are very obvious. And you're flying as a pair down a gorge, tracking your mate in front of you. You've got a very good idea of what the risks are. And this is a clip from Christine, from some of the cave diving groups, sump diving. Again, the risks are known there. Very obvious. But things don't always go well and always to plan. There's a chance that the risk may be realized and end up bad. So this is the same guy jumping off Table Mountain. Broke both his legs, survived. Ironically, when I was looking for videos like this, I came across another one where his buddy had flown into a bridge. And this was his comment of, what happened to your buddy? I knew what happened. He tried to clear the bridge by only 5 feet. And yet, he's trying to pop balloons at a similar distance. And people's risk perception changes over time and experience as well. So it's not simply a case of the risk is static. It changes as you go through time. The next clip is not just risk at an individual level. This is a B-52 at Fairchild. The guy who was flying it was one of the best handlers of an aircraft, but he'd been known to take consistent risks and was breaking the rules all the time. Bear in mind, the aircraft's got a wingspan of about 180 feet, and he crest this ridge at about 30 feet. And they stopped filming because they thought he was going to hit the ground. He was a known problem within the flying organization. In fact, the aircraft, when it crashed, he was the boss of the standards unit. There was a station commander on board, there was a wing commander on board, and there was another senior field officer on board. One of the guys, that was his last flight in the Air Force. It should have been, and it was. His family was waiting for him to get off the aircraft and have a celebration to say, that's it, finished flying. There were lots of failures in the system as to why that accident happened. So you say, okay, make things safe. Does that mean that it's an absence of risk? But you can't prove a negative. Or when you try and say, I'm going to improve safety, I'm going to reduce the fatalities more and more. But the only way you find out that you have improved things, nothing else happens. How do you know you've had an effect? But safety really is the ability to undertake activities when things go right most of the time and when things go wrong. And understanding why they go wrong, that's the hard bit, because a lot of it is all about human behavior. And we change our attitude to things as life goes on. So as part of my PhD that I put together, I'm undertaking at the moment, I try to find out some causality models from existing environments. Cause and effect trees. Denoble, some guys might know from Dan, did some work a few years ago trying to understand the triggers behind diving fatalities. The model that I put together as part of the PhD, the Human Factors Analysis and Classification System diving, something called efficiency thoroughness trade-off, and I'll go into that in more detail. But really need to take a systems approach to the problems we're trying to solve here. It's not just people making mistakes. People make mistakes because of the environment and the culture that they've been developed. But to start off with, You wonder why I've got a picture of Kevin Bacon up here with sort of 6 degrees of separation. What I'm trying to show is that there are lots of ways of linking what would be abstract ideas. And the view is that you can link anybody in the world by going through 5 or 6 other people. So from an incident causality point of view, it's very easy to sit there and go, he died because he did this, or he died because he did that. It's not as simple as that. This is the simplest model that everybody sort of picks up and goes, cause and effect trees. It's very bimodal, do this, do that, do that, do that, off you go. But there are problems with that. You introduce biases and your views of the world. So going through some examples, I've got a choice here. You could have as many choices you want, but I broke it down to 3. Then you've got 2, then you've got 2, you've got 2, and you go, great. That's the series of choices I have, and I got to a point. When you look at the accident analysis, you go, great, that's why it happened, and I can go back and say, he ended up dead because he did that. But the problem with that is you've already got biases. You know what the outcome was, so you're always looking for something to confirm what you've decided is the reason. And you're always looking for those. So it's really difficult to divorce yourself away from that when you know what the outcome is. And there's plenty of evidence out there in other environments to say people, even when they try and make themselves independent and not know what the outcome is, they still judge it. And this is an example here. So you make a decision based on your previous history, your knowledge, your biases, your experience. And there are a variety of outcomes. You can have a good outcome and a bad outcome, but it's never easy to draw that line between the two. What you do then, you take that knowledge and you feed it back into your sort of decision-making loop. If it was a bad outcome, you know, you don't do that again. If it was a good outcome, decide that's a good thing. The problem is, when you decide that something was bad is good, and you feed that back into your decision cycle again, so the next time you come across that environment, you make a bad decision, but you think it's good, and you further reinforce that. So things like not analysing your gas. It didn't bite you this time. I might not analyse it the next time. And you keep on doing this, get to the stage where you just don't even consider it. But then this time you don't analyse your gas and it's wrong. And you end up with a problem where you're reinforcing bad decisions. So the next model was Denoble. He looked at 947 fatalities through the Dan records over a number of years. And he came up with this sort of model of triggers, disabling agents, disabling injuries, and then cause of death. These were quite scary figures. 41% of the fatalities had out of air as a trigger. To me, that is totally unacceptable. All of the agencies teach monitor your gas. But why are people running out of gas? That's just, you know, is wrong. 20% of fatalities started with entrapment as the trigger, and then they ran out of gas is normally what happened after that. And equipment problems. This wasn't equipment failures. This was people not being able to use their equipment properly. Trapped in an SMB, the kit not working, them not using the kit properly, rather. And whilst it was a very thorough analysis, it only said what happened, not why. Why did 2/5 of the people run out of gas? So the view trying to take with the research was, let's take a systems approach to this. The old models in aviation, nuclear power, it was the equipment that broke. Let's fix the equipment, make it more reliable. And that's happened. Aircraft, power installations, diving equipment is now really reliable. It's very rare that it fails. It's okay, we've now fixed that problem. It's the human. We've got to increase the training, make them better. And it's this pilot error. The aircraft crashes, pilot error. Well, actually, they are part of a system. We need to understand what environment they were in, what was the equipment doing, what else was going on in their mind, and trying to take a much bigger approach on what's going on. If somebody is not doing something right consistently, there's likely to be a failure at the organizational level. And I think this is where GUE does very well. instills a mindset about being very good all the time. And complacency is trying to be pushed out. And that is led from the top down. If we look at the timeline model at the bottom, you have simple cause and effect type tree models. Then we look at something I'll come on to in a minute, active and latent failures, setting somebody up for the fall and the accident happening itself. Now we're looking at non-linear models, and one of the biggest problems we have in diving is there is normally a large time gap between a training situation and an accident happening. I hold 4 agency qualifications. If I have an incident or an accident, whose fault is it? It's not one of the agencies. My time, my experience, my knowledge and biases have developed over time. So when people go, you've looked through the analysis, which is the most dangerous agency? Irrelevant. It's the mindset that goes with that. It's not an agency problem. The same with the equipment. In the main, the equipment itself is reliable. It's the person involved as part of that wider system. So something a guy called Holnagel put together was efficiency, thoroughness, trade-off. It's all about shortcuts in life. There's never enough time, money, resource, equipment to do what you want to do as well as you'd like to be able to do it. And so you make shortcuts. The one in the bottom left as you look at it is the bottom of a digger that's driven through a bridge, reinforced concrete bridge. The guy wasn't paying attention to what was going on, hadn't realized he was going to a bridge that was much lower than his digger was. People try and work out ways to get things done more quickly, and that's where the complacency happens. Then looked at something called performance variability and said that actually that's what humans do very well. They recognize the situations they're in and try and change how to do something to get it done more quickly. If we had to do everything by the book all the time, we'd never get anything done. Driving. To reduce accidents, let's drive on the motorway at 20 miles an hour. Yeah, you'd reduce all the accidents, but you'd never get traffic going anywhere. People make compromises all the time. But then you get something called normalization of deviance. And this is one of the solid rocket boosters from the shuttle, where people made bad decisions, something bad didn't happen, and they reinforced that bad decision. And it gets to the stage where it becomes the norm to go and fly the shuttle when the O-rings that were between the solid rocket boosters on the joints should have been grounded, and they should have changed them. But because it didn't happen, they didn't lose the craft straight away, it reinforced that bad decision. We do that ourselves. Every time we deviate from what should be the normal process and we reinforce that bad behavior, it becomes the norm. And so you get further and further away from what is the proper way of doing something. So the model I put together is based on some work by James Reason and Chappell and Weigman. And the idea here really is that the holes need to line up before the accident happens. But it's not simply one set of holes lining up. There are lots of different layers like that, some of them happening in serial and some of them happening in parallel. Problem is we've got within diving incident literature is trying to find the evidence. The original HFACS model was put together looking at hundreds of aviation accidents, detailed reports that you could pull out themes, categories, and say, you could clump them together and these were the reasons. That doesn't happen in sport diving. So what I did was I went through a whole number of literature pieces out there, reports, journal articles, conference proceedings, and pulled out 232 factors which contributed to an incident. I reduced those down using subject matter experts to 96. And then asked those subject matter experts to score a number of scenarios that I'd written, 10 of them, as to what was a key factor, a major factor, a minor factor, or nothing at all. And the bit with the graph here that we've got just shows that there is variability between what people were scoring. So for this one here, and this is the scenario that I'm discussing, there were a number of key ones here, bit of poor decision making up here. But if you look at this one here, there was variability between the subject matter experts. And that also exists in the literature to show that people's assessment of causality is based on your own biases, preconceptions. If I look at a recreational diver and see why they made an incident, I will judge them based on my knowledge. And it's really hard to separate judgment from your own experiences. Looked at rules and violations, and people say, oh, they broke the rules. There are no rules in diving. There's some good practice, best practice, the stuff that the agency teach. But there is no law that you have to do something in diving. It's your own personal risk, which makes it hard to find out whether or not people were doing the right thing or not, because that's their own choices. There are only 5 of those factors out of the 96 they came up with which were equipment-based. The rest of it was all behavior, decision-making, medical factors. One of the big ones that came back on the feedback from the subject matter experts was fiscal drivers. You've gone out on a dive, you've invested time and money on your equipment, on the gas, on the boat, and a bit of kit breaks, and you go, yeah, okay, I'll take it, I'll risk it. Because people don't want to give up their diving. Latent medical issues. Richard's presentation earlier talking about medical fatalities within closed-circuit rebreathers. There are a number of issues that aren't even picked up in normal dive medicals or commercial dive medicals. It's only in a post-mortem, or in my case, when I got bent, I didn't know I had a PFO. I did find out in Malta, but, you know, you don't know that you've got some of these issues because they're not picked up in traditional medicals. But what we did said was maybe there is something where you can say direct contravention of training. So things like not ditching weight belts on the surface or not maintaining positive buoyancy. So go back through the study now, or the case study. Pre-dive, the guy had partly used the scrubber. They planned a shallower dive, say about 50, 60 meters. And he was willing to go and dive with that partially used scrubber material. They then went on an 80-meter dive. What also is they were driving back and forth between the dive sites. I don't know, I'm supposing or surmising. There may be some settling of the sorbed material inside the scrubber. They were late on site. The guys ended up jumping in, the tide was running, they were rushing, breathing hard. Maybe that brought the CO2 levels up higher than was planned. The alarms, as I said, they went off. Don't know why he was ignoring them. He was recognizing that it happened, but then again, if he was suffering from narcosis, his decision-making would have been clouded. Not ending the dive the first time. Why didn't he end up back on the boat after the first ascent? Peer pressure or inferred peer pressure to carry on diving. To change the SPGs, the reason why he couldn't see, so basically he'd gone down, he'd bailed out, breathing rate really high, and he was worried about running out of his bottom stage gas. Previously, he'd had a high-pressure hose failure, so he changed the SPG to button gauges. He now couldn't read the button gauges because they were on the stage. And the reason why he wanted to change over to his 50% early was because he thought he'd breathed the bottom stage down. So again, there's something that's contributory, which on its own wouldn't have been a problem. But because it's all linked together, it becomes much more difficult to separate it. Emergency training, as I say, he'd had about 1,000 hours on unit. He'd never done any practice bailouts or anything else like that since his training. He'd never done gas switches on the handsets when he bailed out. It's something that he hadn't practiced and as a consequence was out of practice. And the narcosis. Looking at the video, he was sitting there going, you know, every 5 seconds, looking at his handset, wondering what was going on. So when I sent it out to the subject matter experts, they came back with these 7 factors, broke them down into the categories. So we go back to that small world problem where you're looking at 6 degrees of separation to get back to anybody in the world. You're now looking at 7 factors here that contribute to the accident. They can all link together, but they're not necessarily directly linked. They're not linear. So it's really difficult to say, This is the reason why it happened. And that's the hard bit when we have is trying to judge post-event where we need to focus on changing things, changing equipment, changing training. It's very difficult to separate that. There is a real lack of data when it comes to incident reports, even just people making mistakes on their own. And when people are involved in accidents, I was involved in one in the summer where we had 8 people on the boat, somebody got bent and they got choppered off. And I thought, great, I can now make something out of this, I can get some research out of this incident. And I asked people to write what happened there and then. So there were 8 people on the boat, and there were 8 slightly different reports came back. Which one was right? People have different perceptions as to what happened on that dive, and why, and what the causality was. So it's very easy to sit there and go, write it down. I'll wait a week, I'll wait a month. When I went back a month later and said, can you give me the same sort of mind dump and tell me what you think happened on that dive, I only got 3 people reply to me. You know, there's a real apathy to try and understand why things happen. And that's just natural because it's not part of our psyche and our culture within the diving. Bad things happen, so be it. That's part of diving. But this statistics and lack of data causes us problems. Richard put this up in the slide, talking about 4 equipment failure problems within the closed-circuit rebreather report that he cited, which was from the Dan Fatalities workshop in 2010. To me, those 4 equipment failures are not equipment failures. So actually, from the 75% human error bit, you're talking up at sort of 90 to 100% are down to human error. And the problem is when stuff gets published to say, there you go, 4 of these were equipment failures. That's out in the open. People then copy it and go, there you go, this is the reason why. No, it's not. But we don't want to blame people, especially our peers. When things go wrong because people made mistakes, we don't want to blame our peers because they're our friends and we don't want to sully their name. The bit underneath about no checklist found in a dead CCR, so what? Every pilot carries out a checklist, but they still crash the aircraft. Just because you don't have evidence of a problem doesn't mean that that is the problem. I think the way that GUE are looking at doing the checklists is actually having an active part to it, that you sign it and you make somebody else, another team member, responsible for checking that. In the same way in cockpits you have challenge and responses for checklists. So you have one person reads it out and the other person does it and they check. So having a proactive checklist method is really good. So how do we improve things? We need to change attitudes. And I think this is again an area where GUE can try and influence the rest of the community. We need to stop throwing rocks at people. Everybody makes mistakes. Those at the top of their game still make mistakes. And from this model here of safety culture, we're somewhere down the bottom of the ladder, easily. That's just the way it's done around here. Carry on. Rather than exploiting and understanding why incidents happened. And it was a point that I was going to try and raise last at the CCR bit is, at the Rebreather Forum 3 last year, they were talking about data logging in rebreathers and the ability to recreate an accident from the data, in effect a black box. And it was recommended that any new rebreather has a detailed data logger. And I think that's one thing that, if GUE's got any influence, is to try and get that done and provide a tool that allows you to do a debrief using the kit. It's very easy to sit there and try and remember what happened or not remember at all. But if you've got something that allows you to do the data logging, you can see what the system is doing when something goes wrong. But we need to change attitudes, as I say. Promote that personal responsibility. When I wrote a paper a couple of years ago about diving safety, I had a lawyer in the States come back and said, fantastic, everybody should read this. But there's a couple of words in here that the Americans won't like. It's personal responsibility. You're always looking for somebody to blame. You get in the water, you go diving. It's your choice. And we all make mistakes and try and mitigate those risks there. But the problem is when we end up with small groups, especially with the egos, And the attitudes of some of the people at the top end of the game, it's really difficult to say no. Especially when you've driven 2.5, 3 hours, 5 hours out to a wreck. The weather's rubbish, you're bouncing around. You might get back on the boat, but we'll give it a go anyway and hope it's okay. Hope's not a way to plan a dive. Sometimes it is, but again, it goes back to what's your level of risk, perception, and acceptance based on what you're trying to do. One of the things that I've been trying to do is develop something called just culture. To be non-judgmental based on what's presented. And that's really difficult because we've got those cultures. We are part of a group and we decide what is right or wrong, even if we don't mean to. The who decides bit, unfortunately, it's normally the lawyers set out the case as to what is provable, which isn't necessarily the same as what is right or wrong. And the same thing happens within our own groups, where you see something bad or not best practice being shown or being done. It's very easy to be judgmental. It's much harder to go up and say, have you thought about doing it this way? But it works the other way back as well, in that people don't want to be told that they're doing something wrong. They've invested considerable time, money, effort into doing what they've done. And if you told them that their piece of kit is rubbish, it's likely to kill them, you know, they're going to get really defensive. So it works both ways. Within the UK, there are sort of 3 main groups. You've got the recreational fun divers who don't sit in any supervised structure. You've got volunteer instructors, British Subaqua Club or Subaqua Association, who've got a duty of care to their students, but they don't necessarily come under the same professional regulation that the professional instructors do, who come under the health and safety executive. They have different needs, and it's very difficult to say, fun divers, you need to do what the professional instructors do, because they'll tell you go get lost and go off and do it anyway. We need to work together to share this data. We need to improve the reporting that's out there. The model there on the right-hand side, nobody knows everything about any incident. They don't know what they're going through the mind of the diver. His buddy might not know it. Don't know what happened at home. A researcher goes around and tries to find some of this information, but he can't get it, but he might find some other information that's out there. And so you end up with a smaller pool of what really happened in one place. One of the things I found during the research is that Dan America, Dan Europe, Dan Asia Pacific have all got their own data sets, and they don't share the raw data. The British Subaqua Club doesn't share the raw data. So there's lots of information out there that nobody can use to conduct detailed analysis. So you end up with stuff that's published in the reports, the journals, the conference proceedings, which is potentially flawed because somebody has already made a judgment call as to what that causality is. So what I'm trying to do is put together a common model that people can score or analyze incidents against, so that even though you can't get access to the raw data, you can try and aggregate across the whole sort of global community. But the problem is when you've only got maybe 15 fatalities a year, and they're normally at the top end of their game, people don't want to talk about their friends messing up, making mistakes. And that's something we need to change. So the idea of the DISMS database was really to provide a means by people could read reports, public reports, but the level of detail was determined by the reporter themselves. And one of the big things that come back from outside other environments, aviation, medicine, is you need to provide a feedback loop. There is no point in collecting this data if it just sits in a database somewhere. The same way we were talking about Project Baseline yesterday. There's no point in collecting all this really useful information if it's just going to sit there. So what happens whenever I put a report in here, I'll post it on Twitter, I'll post it on the Cognitas website. And so you can search for the hashtag DISMS and it will provide a feed. And I've had a couple of forums use this as a means of just listing their incidents. And that's not just UK-based, it's overseas as well. So if you're interested in getting feeds from the DISMS database, you just subscribe to that Twitter feed and put that hashtag in. But in summary, risk and safety are compromises. We want to be as safe as possible, but we know we can't be because we're undertaking a risky activity. We have to decide what is acceptable. And it's not absolute risk, it's your perception of the risk and what you want to say is acceptable to you. There are just too many factors out there to say you can use simple linear models. You need to look at this in a much bigger systems-based approach. And you need to share the data. There aren't that many fatalities happening. In the UK, it's between 10 and 24 over the last 10 years. That's not very many. You need to look at the near misses and understand why those near misses happened. And people need to write the context into their incident reports. Not, I had a DCI, I had a rapid ascent, I got bent, off you go. Well, that doesn't tell me anything, really, other than you got bent. It doesn't tell you why. It doesn't tell you whether or not you were experienced in that environment, whether or not your equipment you were using your equipment properly. But that requires a bit of soul searching for people to be honest with themselves. But ultimately, we can improve things. And whilst I can give presentations like this, I'm very grateful to Jared for inviting me. 2 weeks ago I was at Baltic Tech. Giving presentations like this is really good. But it requires the leadership of the agencies and the senior guys to feed down to the membership and to their students. There are lots of old dogs out there. I'm not going to change those. But what we can do is try and change the attitudes as training goes on, so that we recognize everybody makes a mistake, and ultimately that mistake may cost you your life, and try and mitigate the risks that are there. And this is the frustration, is you look back and you go, 20/20 hindsight, I wouldn't make that same mistake. Well, in that case, change your own procedures, your own ideas, what your risks are. If that means you need to go and do some more training, go and do it. If it means you need to break some or change some kit that's broken, go and do it. If it means not diving with somebody because they're unsafe, go and do it, or don't do it. So that's my presentation. Happy to take any questions.